Okay, so here we're going to have another example of linear regression or predicting values using linear regression. So we will be using uh, yun pa rin, yung Python, and we'll be excuse me, we'll be using actually the yung mga libraries like numpy, matplotlib, and scipy. Okay, so first here we're going to import the libraries. So we have import numpy as np, import matplotlib.pyplot as plt. So this will be we will be using this to plot the diagram. So actually that is optional if you want. And from scipy import stats. So we'll be using scipy for our linear regression. Now actually there are other libraries that can be used for linear regression, but in our case we're going to make use of scipy. Okay. First is we have here the data set. So what we're going to do here is to predict, for example, the sales depending on the ad expenses. So yung ads. So if there's a relationship, then we can actually make use of linear regression. So assuming, for example, we have here the advertisement expenses is equal to, we convert it into an array. Actually, it's optional, but in our we need that, we need the array in our diagram later on. So we have 200, for example, 400, 600, 800, 1000, and 1200. But of course, in actual cases, we have bigger data set. Then maybe we have here sales is equal to np dot array. I'll be providing the source code later. Say when we spend 2,000, our sales was 2,200. When we spend 400, our sales, for example, is 2,500. So when it is 600, assuming it's 28. So of course, it's actual. You have to record this and then look if there's a relationship. Okay, so let's say, for example, this is our data set. So just a brief example. So now we're going to perform linear regression using scipy stats. So to do that, we have here the slope, the intercept. So it's actually a straight line. We're using a straight line, and then to get a value, we need these values: the slope and the intercept. So R, P, you have to look at the statistics. If, let's say, for example, yan, yung mga P value na yan. But here, we'll be interested in the R value. So, and then equal now to stats that regress. So, linear regression. Then we use, for our X value, the ad spend, and for Y, we have sales. Okay. Then maybe display regression details. So we have to print the slope. Usually we call it M. Print intercept, the B. We also print r squared. So here, if you want to test if, let's say, you can actually use linear regression, you have to test for the value of r. R should be approximately equal to 1 or negative 1. It should be approximately equal to that. If it is very far from 1 or negative 1, then that means that maybe we should not use linear regression for our data set. So yan, then yung matetest if, let's say, we really can use linear regression. Then next, we plot the regression line. So x values is equal to np. I did not use r value, I use r. np dot lean space mean add spend max add spend 100, and then y values, so we're actually slope times x values plus intercept. Okay, so plt dot plot, oh no, intercept, plt dot plot, you have the x values, and then we have the y values. Let's say color equals red, label equals regression line. So yeah, it says here, para to create a line, yung sa x, we are generating a number from the minimum value of ad spend to the maximum value of ad spend. So parang 100 sets of data. And for each 100 set of data, using the slope and the intercept, we generate the y values. Okay? Para mas maganda yung line natin. And then we just plot the x values and the y values. If you're going to print this will actually generate numbers. Okay? So parang siyang gumawa ng number. Basing from the minimum ad spend and the max ad spend for x. Ito naman, using the slope and the intercept computed here, yeah, it will generate the y values. And then here we plot the linear regression line, the regression line. So we place labels and titles, plt.x label. So this will be for the advertising spend in pesos, kunwari. So our y-axis label, regression. And then we have plt.legend, plt.show. Hopefully I don't have any more errors. So these are just labels, and then so let's save this. I haven't tried it yet. So documents, UL files, class project, Python, new folder, Ili 003, 223. Then regress demo.py. Okay, so that is our program. Let's double check. So first, let's again recap. So we imported the necessary libraries. So you have numpy as np, matplotlib for our graph and scipy.stats. So numpy to convert this to array. Although if you are not going to plot, if you're not going to use this one is optional. You can actually go directly to just a list here instead of converting it into an array. So next, here we have our data set. We converted the list into an array, NP, so using numpy. Again, it's optional to convert this into an array. So we have the data set, we have the ad spend and the sales. And then we perform the linear regression using scipy.stats. So here we did not use this one yet, but here we have to test this. So if you want to be sure that you can really use linear regression here, you have to check the value of R. Okay, if it is equal, it should be equal to -1, 0, or +1. If it is far from 1, let's say 0.3, -0.3, -0.2, then that means maybe you cannot make use of linear regression. It is not a good fit for this particular data set. Maybe you can use other regression techniques. Okay, so after that, we just printed the value of the slope, intercept, and R. Oh, but wait, I did not predict the value. Before that, let's predict a value, for example. Predict sales for, sabihin na natin, maybe 1.5 ad spend. Okay, so how do we predict that? Predicted sales is equal to, you have the slope times 1/500 plus the intercept. Okay, so this is the value. Yeah. So that's how we compute for the prediction. Again, if it is fit, then we just print the predicted sales. Sales for PHP 1/500 ad spend. So we have gamma predicted sales, so that it will be more appropriate. Yeah, I think so. Here we're going to predict for the sales. Predict sales for a 1,500 ad spend. So we just make use of this formula for linear regression. So linear regression is actually a straight line. That's why we can use this formula. So after that, we just plot the diagram. So again, this will generate 100 values, equal distribution from the minimum value of ad spend and to the maximum value of ad spend, which is actually from 200 to 1,200, so 100 values. And then using this formula, we also generate 100 of this, okay, 100 values. And using those values, we now plot our regression line ito. So, a PLT plot, I think this should be, PLT plot? Wait. Yes, that's PLT plot. Pero, yan yung line. Okay, wait. I think I forgot something here. I have to make my scatter diagram. So for this scatter diagram, so that we can see more or less if our data are quite near the values of our linear regression line. So PLT dot scatter, we have here ad spend, then we have sales, color equals blue, so that label actual data. Okay, so we have to plot our scatter diagram first. So using X, ad spend, sales for Y, and using the color blue, and label is actual data. Here we generate the values and then we plot regression line. So this will generate a line. Okay. Then here, these are just labels. So let's check. Hopefully there's no error. cd ul files, cd class projects. So cd python. cd elected 003 223. Yeah. So python lean regress demo.py. Yeah. So this is our plot. Yan yung line natin. So actually talagang so eksaktong-eksakto basing from the data. That's why if you notice here, our R is equal to 1 kasi talagang saktong-sakto sa line. But of course, reality sometimes hindi ganyan. Okay? So our slope is 1.5, intercept is 1899. Okay? So yeah, this is the output of our predicted sales. So if we have 1.5 spend, so predicted sales is somewhat around 4,150, 415. So let's say 1.5 nandito. So nandun sa taas. Kasi 1.5 dito yon. More or less nandito sa taas yung intercept. So let's say for 800 or pang 700, yan. Dito yon. So more or less around 229, parang ganon. If we're using 700 for our advertising expenses. Yeah, so that's it. Anyway, I'll be pasting the code sa YouTube mismo. Okay, so thank you very much.